Hi everybody. So today we're going to be solving some right triangles. But before we start solving, I just want to make sure that our calculators are in the correct mode. So when you check your calculator, hit the mode button that's next to your second button. Just make sure that on the third line down, you have this degree highlighted instead of the radian. And if you've done that, we're ready to solve some triangles. So when we say to solve a right triangle, we really mean to find all side lengths and all angle measures. So there's a lot of different ways that you can go about doing these solving. I'll show you kind of the way that I like to do it, but you can do this in any number of ways. So I'm looking at triangle ABC over here. I notice that I have two angle measures and I have one side length. It does not matter if you solve for the angle measures first or the side lengths first. I usually like to take care of the side lengths. So I'll just go ahead and mark one of my unknown side lengths as a variable. I like to use X and Y, which we'll see in a second. And then I want to look from the angle that's given, that's not my 90-degree angle. And from here, I decide which two side lengths these are. So from my 72, this X would be my opposite. And then the 72 would mean that my 15 would be my adjacent side. So because I have opposite and adjacent, I'm going to go ahead and set up my tangent ratio. And I'm going to use tangent of my angle 72 degrees is equal to my opposite side of X over my adjacent side of 15. And to solve here, to get rid of that fraction, I'm going to multiply each side of the equation by 15. So I get 15 times the tangent of 72 degrees equals X. I'll use my calculator to go ahead and calculate that out. Rounding to the nearest tenth, looks like that will be about 46.2. So X is about 46.2. And in my diagram, I'm noticing that I put X as my side BC. So I'm going to say that that would mean that side BC of my triangle would be 46.2. So there's my first missing side length. So then I still need to find my side AB. And you can call this whatever you want. I like to use a different variable Y. And you can do this actually a couple of different ways. If you have two side lengths of your triangle, you can go ahead and use your Pythagorean theorem. You could, in fact, use a different trig function if you wanted to use cosine, or you could use sine to find out what y is. So you have a couple of options here. I find that if I know two of my side lengths, using the Pythagorean theorem is a little bit easier. So I'm just going to go ahead and set it up that way. So 15 squared plus 46.2 squared is 2,359.44, and that's equal to my hypotenuse of c squared, which I called y, so I guess I could use my variable y. And then to solve for y here, we can square root it. So that gives me about, in my calculator, 48.57, so about 48.6 if I round to one decimal place. And again, I marked side y as my side length AB. So I'm just going to go ahead and say AB would be about 48.6. And the nice thing about this is you can kind of check for reasonableness, because remember that your hypotenuse should always be your longest side of the three. So 48.6 is longer than these two sides. So then the only piece of my triangle that I'm missing here is my angle B. The nice thing is I know that the total measures of a triangle add up to 180 degrees. So if I have two of them, I can just use some subtraction to find out what the measure of angle B would be. So my total is 180. And then I can go ahead and subtract out what I know about my 90-degree angle and my 72-degree angle. And I think that leaves me with 18 degrees. So measure of angle B would be 18 degrees. And that should be the last piece of information, because now I have all three sides and I have all three angles. So I'm done solving this triangle. Example 6 is a little bit different just because in here I only have one angle. I'm missing angles D and F. I usually like going and tackling the sides first, but again, it doesn't really matter how you do this. I'm going to find side DF first, which is my hypotenuse here. So again, since I'm given two sides, I can go ahead and use my Pythagorean theorem. So 21 squared plus 22.5 squared is equal to my hypotenuse of x squared. These two would be, I think, 947.25. And then to solve for x, I can go ahead and square root that. So x, if I round to one decimal place, would be about 30.8. So that means that this side length of my triangle, DF, is 30.8. Okay, so now I have to go and find my two angles here. So it doesn't matter which angle you want to find first, just pick one of them. I'll pick angle D, and I'm going to mark angle D with my theta, because that's an unknown angle, would be using theta. And then from there, I have options of what I want to do here. Usually I like using the given sides. So I'll go and work with those. So I have an opposite side and I have an adjacent side. So with my theta, I'm going to set up my tangent ratio. So my tangent of my unknown angle theta is my opposite side of 22.5 divided by my adjacent side of 21. And here's where we're going to need to use the inverse trig, because I want to find an angle. So anytime I'm looking for an angle, I want to use inverse. And now I'm going to be using the inverse tangent. So my theta is going to be equal to the inverse tangent of 22.5 over 21. So inverse tangent, second tangent, 22.5 divided by 21. I get about 46.97. So if I try to round to one decimal place, that 7 is going to round the 9 up. So this actually ends up being about 47 degrees. So theta is about 47 degrees. And theta was my angle D. So I know that the measure of angle D is 47 degrees. So now I have a 90-degree angle, I have a 47-degree angle. I can just use subtraction like I did in the last triangle to find the measure of angle F. So measure of angle F would be 180 degrees minus 90 degrees and then minus 47 degrees, which I believe should leave us with 43 degrees. So measure of angle F would be 43 degrees. And that should be my last piece of information, because now I have all three sides and I have all three angles. So I'm done solving my triangle. And now it's your turn to do some practice. Let us know if you have questions, and good luck.